Assalamu alaikum everybody. This is me, Khalil Al-Houthi, your instructor in General Geophysics course. So this is the lab I supposed to give last week. I delayed it for some reason because during this lab today, actually I will give a lecture instead of a lab. And I give you this lab to work on submit within the end of this week, probably by Saturday. So the lab itself is about how to locate an earthquake. Basically, whenever you want to locate an earthquake, you need to determine what is the surface coordinate of this earthquake, at what location exactly it happened. And to know this information, you need some information. You need basically stations or what we call um, seismometers that record the energy emitted from the earthquake. Usually, we need the minimum of three different stations. So, the minimum requirement is to have three stations. Another requirement is that we need two kind of seismic waves. One of them is the P wave, depicted here as green arrow. And we also need the S wave, shown as a red arrow. P wave is the fastest, followed by the S wave. So in this figure, that's basically a seismic wave or a trace recorded as at a seismic station, and it has different types of wave arrivals. The first wave is the P wave. That's the P wave. Exactly. Here is it. If you see my mouse, that's where the arrival time of P wave is. Followed by S wave. That's the S wave. So this is the difference in time between S wave and P wave. Followed later by Rayleigh and Love wave, what we call surface waves. So in this lab, you are given data from four different stations. So the first station is at San Andreas Observatory. The second one is at Stanford. The third one is at Mount Hamilton. And finally, the last one is at Berkeley. On the map, if we go back to the map, that's the map. So here we see Lake Observatory, San Andreas Observatory, and we see also Berkeley Observatory, and finally the Stanford Observatory. These three triangles are, or these four triangles are actually the the locations where we have stations. Each station recorded seismic waves, and we need to define where is the arrival time, at what time is the arrival time of P and S exactly. So how you can read this information? Let's take the San Andreas Observatory and try to get where exactly is the P time and S time. So for P time, this is the onset of shaking. And that's the onset of P wave arrival. And I can locate it exactly the time reading the time axis. So the red line here, the start of this red line here exactly is 20 hours and 36 minutes. And each segment vertical line is exactly 3 seconds. So here the time is exactly here. At this specific point, the time is 20 hours, 36 minutes, and 3 seconds. So if we Keep increasing every time 3 seconds for respective vertical lines. The final one here gonna be 36 minutes and 45 seconds. Here exactly the red line. And we keep continuing. So that here gonna be 20, 36, 45 plus 3, 48. Here 51. This is 54. Here exactly at this line. However, the onset is slightly lower than 54 seconds. Means 20 hours, 36 minutes, and somewhere between these two lines. So try to guess it yourself and give the number. Plot or bring the number, write it down here. I have written it already for the first one. You have to do it for Stanford, Lake Observatory, and finally Berkeley Observatory. You need to bring as well as P wave and S wave time. Then subtract the time. Subtract S wave from P wave. So, for example, for San Andreas, the first one, San Andreas Observatory, we find the S wave is somewhere here. That's the location of the S wave. And it's already recorded for you, written for you here. Do the same for the remaining seismograms. That's the second one. In Stanford, this is the P wave, that's the S wave. Here is the P wave for Lick Observatory, and this is the S wave. Finally, for Berkeley, this is the P wave, and here is the S wave. That's the S wave. Get these numbers, write them down here, find what's the difference. So you need to get the difference and find what is the distance then from the epicenter or the surface location of the earthquake to this site, to the station site. For example, for this first case, that's 40 kilometer. And how you can find it? You need to find this difference time. So let's assume we found it that it's 5.5 seconds. We take this number, come here to this graph, and there is a line S minus P wave time. So for the first one, it was 5.5 seconds. Draw a line that's uh, parallel to the x-axis. So this is the time axis. This is the distance. The x-axis is the distance. The x-axis is the distance. So draw the line and let it connect with this graph, straight line, S minus P. Once it's connect with this graph, bring it down, bring it to the x-axis, and record at what value it crosses the x-axis. In this case, it crosses it at 40 kilometers. Do the same for the other two or other three, and record the value here. And try to answer these questions. Examine the four. So, which of them is the closest to the epicenter? Which of these locations is actually closer to the earthquake location? And which one is the farthest? And basically, you can tell by the difference in time between P and S. The larger the time, it will infer something, whether it's close or far. You have to decide yourself. Then once you get this distance, that's 40 kilometer, come to this map, convert that distance to kilometer. So this distance in kilometers. For this case, that's 40 kilometer. That much is 40 kilometer. Use a protractor. Use a protractor and draw a great circle with how much? 40 kilometers. That's 40 kilometers. So that's the first circle. And you have to draw 4 circles. For each observatory, there's going to be 1 circle. And the point where all these circles meets or joins, that's the location of the earthquake. That's basically the location of the earthquake. So you need to locate the earthquake on the map. That's the first question, question 3. Then you need to define what is the P wave arrival time at another location, at some location where there is no observatory, no seismic station. So Santa Cruz is a place in the map. Try to find it. Try to find where is Santa Cruz. We have Santa Rosa and other places, San Jose, Auckland, and that's Santa Cruz. The location of the earthquake could be anywhere. Measure the distance from this place to the earthquake. Measure the distance and try to find how many kilometers is this value from the scale you have. That's the scale. So you get the value in kilometer. You need to come back to this graph, get how much is the value. Let's assume the value was 100. That's just an assumption. Draw a vertical line till it connects the P wave times. So let's assume it's 100 kilometers. That's just an assumption. It might not be true. Till it touches the P wave time. Then try to connect this line with the y-axis. Draw it straight till it connects or touches the y-axis. The point at which it crosses the y-axis, that's the P wave time. Assuming that you are joining it with this line, P wave time. So that's for which question? Question number 4. What is the origin time? So to determine what's the origin time, you need to use Excel. You need to use Excel. In the uh, x-axis, plot the P wave times, you found. In the y-axis, plot the difference in S between S and P. You get basically some points. For your case, you'll get 4 points. And connect them through best fit line. That can easily be done in Excel. Right click on any of these points in Excel, and there is an option that to fit straight line. So at the point it crosses the x-axis where the difference is 0, that's the origin time. So this is how you get the origin time. Origin time is basically when the time difference between S and P is 0. You need to have the difference in time of P and S 0. That's the time the earthquake happened. So origin time means the exact time at which the earthquake happened. Because origin time is different than the arrival times. The energy from the earthquake takes some time to arrive to specific location. However, usually we also need to know what's the origin time, exact time the earthquake happened, rather than the time it took to arrive to me or to some observatory. So those are the all questions. Everything is provided in this sheet. You can collaborate with your colleagues. You can ask me questions, and if there is any difficulty, please refer back to me. All the best. Goodbye.